Lensmaker's formula for convex lens. Lensmaker's formula is a relation that connects focal length of a lens to radii of curvature of the two surfaces of the lens and refractive index of the material of the lens. The lensmaker's formula is useful in designing lenses of desired focal length using suitable material and surfaces of suitable radii of curvature. In deriving this formula, we use new Cartesian sign conventions, which are so and so. Derivation of lensmaker's formula for a convex lens. A convex lens is made up of two convex spherical refracting surfaces. The final image is formed after two refractions. P1 and P2 are the poles. C1 and C2 are the centers of curvature of two surfaces of a thin convex lens XY with optical of two surfaces of a thin convex lens optical center at C. Let mu2 be the refractive index of the material of lens and mu1 be the refractive index of the rarer medium around the lens. Consider a point object O lying on the principal axis of the lens. A ray of light starting from O and incident normally on the surface xp1y along op1 passes straight. Another ray incident on xp1y along OA is refracted along AB. If the lens material were continuous and there were no boundary/second surface xp2y of the lens, the refracted ray AB would go straight, meeting the first refracted ray at I1. Therefore, I1 would have been the real image of O formed after refraction at xp1y. If Ci1 is equals to P1I1 is equals to V1 and CCI is equal to P1C1 is equals to R1 and CO is equals to P1O is equals to U, then mu1 by negative U plus mu2 by V1 is equals to mu2 minus mu1 whole upon R1. Actually, the lens material is not continuous. Therefore, the refracted ray AB suffers further refraction at B and emerges along BI, meeting actually the principal axis at I. Therefore, I is the final real image of O formed after refraction through convex lens. For refraction at the second surface, xp2y, we can regard I1 as a virtual object whose real image is formed at I. Therefore, U is equals to Ci1 approximately equal to P2I1 equal to V1. Let Ci approximately equal to P2I equal to V. Let R2 be the radius of the curvature of second surface of the lens. As refraction is now taking place from denser to rarer medium, therefore we get negative mu2 upon V1 plus mu1 upon V is equals to mu1 minus mu2 whole upon R2 is equals to mu2 minus mu1 upon negative R2. Adding those equations, we get negative mu1 by negative U plus negative... Adding those, we get Adding those two equations, we get mu1 upon negative U plus mu1 upon V is equals to bracket mu2 minus mu1 bracket close bracket 1 by R1 minus 1 by R2 bracket close, or mu1 whole into 1 by V minus 1 by U bracket close is equals to mu2 minus mu1 whole multiplied by 1 by R1 minus 1 by R2. Put mu2 upon mu1 is equals to mu as refractive index of material of the lens surrounding the medium with respect to surrounding the medium. When the object on the left of lens is at infinity, image is formed at the principal focus of the lens. Therefore, when U is equals to infinity, V equals to F is equals to focal length of the lens. 1 by F minus 1 by infinity is equals to mu minus 1 into 1 by R1 minus 1 by R2. This is the lensmaker's formula.